Part 5, Section 12.1, Deceptions in Visual Displays of Data. We started this section by talking about a few ways in which statistics can be used to deceive. One of the easiest and most common ways to mislead people is with visual displays of data, often called infographics. Now, we have to evaluate infographics the same way we do any other source. I'm sure you have all been taught in your other classes to ask yourself if a source is reliable before you use it in some kind of research project. A lot of what we're about to talk about is going to sound familiar. Now, these are just a few of the things you want to watch out for when you're looking at data. Is there a title that explains what is being displayed? You need to know exactly what it is that you are the information you are being given. If you're being presented with poll results about likely voters, it needs to say that. Are numbers lined up with tick marks on the vertical axis that clearly indicate the scale? Has the scale been varied to create a more or less dramatic impression? So we can kind of stretch things out or squish things together to make it look like the way we want it to look. You need to make sure that they aren't pulling that kind of trick on you, okay? Do too many design and cosmetic effects draw attention from or distort the data? If the graphic is too busy, your eyes can go everywhere else and not concentrate on the comparison that you're trying to get across. And if they just make your eyes go everywhere, then you're not actually getting the true data. Has the wrong impression been created about how the data are changing because equally spaced time intervals are not used across the horizontal axis? So if we're trying to show the growth over time, but then between these two, there's 10 years, and over here, there's 40 years, but we have them placed close together so that they look like they're the same amount of time apart, that is a way to deceive people. Okay, because it can allow it to be interpreted in lots of different ways. Are bar sizes scaled proportionately in terms of the data they represent? Now, this can be a little bit tricky because we did the histogram and our columns, our bars did vary proportionately, but one of the things that was really important is that all of them were the same width. So they only increased up and down, not left and right. And that's important because our eyes compare area, not just height. So if we start to vary length and width, we're messing with the area and it's not proportional anymore. So we do really have to be careful about that. All right. Is there a source that indicates where the data in the display came from? Do the data come from an entire population, or for a sample, you want to know what it is you're looking at? Was a random sample used? And if so, are there possible differences between what is being displayed in the graph and what is occurring in the entire population? So if they're just using landline telephone polls, then there might be a problem and we need to pay attention to that kind of thing. Now, we're going to be talking in general about margins of errors in polls later, but these are just things to kind of keep in mind. And always, 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 we have to be aware of bias. Who is presenting the visual display, and what does that person have a case to make for or against the trend shown in the graph? What is in their best interest to magnify? That's what we have to look for. I have a couple of example problems. These are all from your book because you don't want me to try to create these graphics myself. And this is just an example in the book, in the chapter itself. And they've given us this graphic here. It's the purchasing power of the diminishing dollar. And the source is the U.S. Bureau of Labor Statistics, about as reliable as you're going to get here. And these questions are asking, why is this not a reliable, what is misleading here? And the length is going up and down based on the differing numbers. But notice how they're getting wide. They start off wide and they get smaller and smaller and smaller. This is decreasing the area disproportionately. Our vertical is proportionate, but the horizontal should not have changed. In fact, it says if the area of the dollar for 2005 were really drawn appropriately by area, it would be twice as large as it is here. So by making that one little adjustment here, that one tiny little thing, it makes the comparison look a lot worse than it actually is. Okay. So we have two graphics here. Describe what is misleading in each visual display of data. So they both have titles, which is good. They both have sources, U.S. Census Bureau, and that's about as good as you're going to get on population, right? And then this source is R.R. Bowker, and I looked them up, and they are basically everything book-related networking company. They connect publishers and booksellers and authors and everything. It's the best I can figure out. So they ought to know how many books are produced. So reliable as far as that goes. This one is about how the population in billions is going up. So they've got the graphic going from left to right, from 1 billion up to 9 billion, and it's scaled up nice and linearly, so that makes sense. So what's misleading here? So now we look down here. What are our years? What is that? 1804, 1927, then to 1960. See, we're 1960 right here. So 1974, those are a lot closer together than those two are. And then 87, 99, 2012, and then they're projecting into the future. So the problem here is that these are not equally spaced. And that's important because it's making our growth look like it isn't speeding up as fast as it is. It's more looking like this than like this. So misleading. Here, the number of the book title output in the US, we have our data across here, we have the years along here. And mainly, we really just want to, kind of compare, and they do vary up and down on the vertically as they should. But again, they're making these things wider. And what's worse, even worse here than here, is that these are 2D graphics. These are drawn in 3 dimensions. So it's the volume that's changing, not the area. And that's even worse. Because if you make a book taller and wider and thicker, then that's a big difference than if you just make it a little bit taller. So again, it's not proportional. So it's just things to be aware of.